paper Kernel-Aware Burst-Blind Super Resolution. This work was collaborated by Uppsala University and Chengdu University of Information Technology. Our code and pre-trained models will be released to the GitHub. Given an HR image, we model the multi-frame image degradation as equation 1. Here k_I means I_th blur kernel. Tau represents some motion transforms. We often use bicubic downsampling with scale factor S, and also add some Gaussian noises to LR images. A simple example of multi-frame image degradation is shown in the figure. The HR image is downsampled with different blur kernels and motion transforms. The main contributions of this work can be summarized as follows. We propose KBNet, the first work addressing the burst-blind super-resolution problem. We further design an adaptive kernel-aware block and a pyramid kernel-aware deformable alignment module to improve the senior results. Extensive experiments demonstrate that the proposed method achieves an art performance on various synthetic datasets and real images. This is the overview of the proposed KBNet. It inputs a set of raw burst images. The estimated blur kernels are sent to the restoration network to obtain the final HR image. We use adaptive kernel-aware blocks, AKBs, and the pyramid kernel-aware deformable alignment module, pyramid CAD, to extract clean features and align frames. Figure A shows the network architecture of the kernel estimator, and Figure B shows the kernel-aware deformable alignment module. This is the pyramid kernel-aware deformable alignment module. Starting from level eth_1, we align all features with reference using COD, and the predicted offset are sent to the next level to be concatenated with features to improve the offset estimation. Then each level's output are upsampled to have the same sizes so we can fuse them to obtain the aligned output features. Table 1 shows the comparison of our method with other approaches on the synthetic dataset. Table 2 shows the comparison on the real-world dataset, and Figure 1 illustrates the comparison of the PSNR performances curves on two dataset among different number of frames. Table 3 shows the ablation studies on the main components of KBNet. Figure 2 shows the qualitative comparison on the synthetic dataset. Figure 3 shows the qualitative comparison on the real-world dataset. In conclusion, this paper presents a new framework, named KBNet, to handle the multi-frame super-resolution problem with considering multiple complicated degradations. We introduce a kernel-based multi-frame restoration network that includes an adaptive kernel-aware block, AKB, and a pyramid kernel-aware deformable, pyramid COD, alignment module. Experiment results demonstrate that our method can achieve a good performance on various degradations and is beneficial to real-world device applications. Thank you.